Eighth grade algebra students, we are looking at example 5 from section 9.2. Here, we can apply the skills we have learned to everyday life. In this example, Consuela built a model rocket for her science project. The equation h equals negative 16t squared plus 250t models the flight of the rocket launched from ground level at a velocity of 250 feet per second, where h is the height of the rocket and feet after t seconds. Approximately how long has Consuela's rocket in the air? So again, I want to remind you that this 250 is represented in our equation as the velocity here. We don't necessarily have to do anything with that 250. It's already represented in our equation. For this problem, I'm going to show you how to use Desmos to analyze a graph to find the solution. I also want to remind you that if we have a rocket and we are launching it into the air, it's going to come back down. It will go upwards and then it will come back down and land. We want to know approximately how long the rocket was in the air. So this time between its launch and its landing is the time that it was in the air, and that's what we will look at. I do want you to go to desmos.com. Again, desmos.com, and you can go, let me check quick, /calculator. That is the website that you can use to get to Desmos. Once you are there, we can type in our equation, but I want you to notice our equation was h equals negative 16t squared. We use this button for square. If you don't see the keyboard, you can select this to show the keypad, and this squared gets you the squared plus 250t. I want you to recognize when we enter this equation as it is into Desmos, remember this is a website, that does get us, if we zoom out, you can use this minus to zoom out, it does get us our parabola that looks like this. So again, this is our vertex, and it's also our maximum. This parabola opens downward, so we know that with a negative a value. So you might want to zoom out just to make sure that you do have a parabola graphed. But our values that we want to focus on are right down here, and I'll show you why those values are important. Again, our h, or our y value, this is how many feet it was in the air. So the maximum height of Consuela's rocket was, it looks like it was about 975 feet. But down here, when we get to 0, there we go. When we get to 0, this is when our rocket is 0 feet. We want to know when it starts on the ground and when it lands on the ground. The time between, our x is our time between, tells us how long it was in the air. So here, we finally can see from 0 to 15.625 tells me that it was in the air between those two times, and it landed back on the ground at 15.625 seconds. So here, that would be our answer. Consuela's rocket was in the air for approximately 15.625 seconds. Your textbook might just round to the tenths place, and that's okay. They probably use a graphing calculator, but Desmos allows us to click and find that exact value. So remember, we are looking when the rocket started on the ground to when the rocket landed back on the ground. And here, we just want to see that answer. If you would like, you can draw a picture to show what the graph kind of looked like, and you can mark the values. You could show our x-axis, our y-axis, sorry, this is bad. This was at 0, and you could mark 15.625 if you wanted to draw a picture for your work to show that you did graph this on Desmos. Here, I want you to, again, use this website, desmos.com/calculator, and practice the same thing solved in guided practice 5.